Hi, I'm Matthew, and we have Abraham and Roland, and we are working on a no-show doctor's appointment data set from Kaggle. Our motivation is to predict whether a patient will show up to their appointment based on 12 or so different factors that can impact their attendance. And by doing so, we can improve patient treatment around the world to see how we can increase their attendance to their appointments.
So this is how our initial data looks like. We have 14 different features, such as like the ID, the scheduled day, the gender, the age, which day they show up, neighborhood it's in, the scholarship, which is basically just government subsidies, hyperextension, diabetes, alcoholism, handicap, whether they receive SMS, and whether they show up or not. And so we need to drop the patient ID and appointment ID in the neighborhood. We also extract the waiting time between when they schedule the appointment and when they actually is going to show up on. And we also extract the time to indicate whether it's morning or afternoon, whether it's a weekend or weekday. We also changed the gender and no-show data to binary data, and we fixed some of the spelling error, such as like the handicap and hyperextension being spelled wrong. And this is how our data after the initial processing looks like. And some of the problems that we find out from our data when we are looking through all the columns is we find that there's age that are negative and age that are too high. Next slide. And we also find out that for the waiting day difference, there's a negative waiting day. And for handicap number, we also see that there are handicap number that are 3 or 4 when it should be indicate whether they have handicap or not. So it should be a binary number. So all in all, we remove some of those data and change them up so that they are indicated correctly.
So we also made a Pearson correlation heat map. And as you can see from it, there's no two features that are strongly correlated with another one. So from this, we decided there wasn't really any correlations that we need to drop from our data set. So we made no feature drops from this. And then this is our training accuracy for the, and testing accuracy for the KNN classifier. As you can see, around 94 to 100 is when the testing accuracy kind of levels out at its max point. So we set that as our preliminary number of neighbors to use. And then as you can see at the bottom, it shows the training accuracy for KNN and test accuracy with 94 neighbors, and it is pretty close to the same as what it shows in the graph, so worked well.
But after we decided to plot the ROC curves for the 3 models that we have so far, and what we got is something very close to choosing randomly. So we were wondering why that was. We also checked the area under the ROC curve, and it wasn't exactly 0.5, but it was very, very close. And the reason that our ROC curves are so close to the random, is because of our class distribution. We have a lot of zeros in comparison to the ones, the zeros being that they showed up to the appointment, ones being that they didn't. So because of this class distribution, the ROC curve isn't a good measure to see the accuracy of our model. So in our future plans, we want to do optimizing of hyperparameters in such as the citizen tree, For that, we're going to use cross-validation. We still need to do our random forest classifier. And to fix the ROC curve issue, we plan on using the AUPRC instead. That's all from us. Thank you, guys.